Okay, looking at undefined points now. So on this problem, let's find the x-intercepts, vertical asymptotes, and any undefined points for this function. The undefined points is the news name. Well, to find x-intercepts, you would set the numerator equals 0. And we have x squared minus 4 equals 0. And then to solve this, you could either factor this into x plus 2, x minus 2, and solve each individual thing. Or you could add 4 to both sides and take the square root to get plus and minus 2. So you get 2 x-intercepts, supposedly, so far. X equals 2 and x equals negative 2. How would you find vertical asymptotes? Well, you would set the denominator equals 0. Setting x minus 2 equals 0, you get x equals 2. Adding 2 to both sides, you get x equals 2. Well, notice this right here. This says that we have a vertical asymptote at x equals 2. In other words, the graph goes vertical at x equals 2. And also, as it gets closer to 2, it goes vertical, I should say. And also, there's an x-intercept at 2. Well, that's impossible. So there's something going on weird in this with this graph at x equals 2. Well, remember this. When the numerator equals 0 and the denominator is not 0, you get 0. Like 0 over 2, 0 over 1, 0 over 10 is 0. Well, when x is 2, 2 squared minus 4 is 4 minus 4, and you get 0 on the top. Well, you also get 0 on the bottom. When you put 2 into here, you get 2 minus 2, which is 0 on the bottom. So this doesn't satisfy, substituting 2 into this function doesn't satisfy this rule. So we don't necessarily get 0. Okay. Also remember that if you have division by 0, that's undefined, and that means there's a vertical asymptote there. Like 2 over 0, 1 divided by 0. As long as it's a non-zero number. Well, it doesn't satisfy that either, because when I substitute 2 into this, I get 0 over 0. Well, 0 over 0 is a indeterminate expression where we're not sure what you get on that. So notice we get 0 over 0 when we substitute 2 into that expression. So how do you know what you have? Well, we can't substitute 2 in an expression, but we can substitute in numbers close to 2. So if I would substitute in 1, I get 3. 1.9, I get 3.9. Substituting in 2.1 into the expression, I get 4.1. And at 3, I get 5. So it seems like the closer I get to 2, and the value that I substitute in, the closer the expression, the function, gets to 4. Now what we can do is try this on Excel. I'll put in the coefficients here into the rational sheet, and I have them in here, x squared minus 4 over x minus 2. And if I put 2 exactly in, I get this little statement here. I got division by 0, so it can't tell me what it is. But if I try in a number close to 2, and like here's 1, that's not real close to 2. And here's 3, that's, well, sorry, right here, here's 3. That's not real close to 2 either, but I get 5. And you might think, well, geez, 4 is halfway between the value I got for 1, which was 3, and the value I got for 3, which was 5. But you can substitute in numbers closer to see. Like, for example, if I substitute in a number closer to 2, like 1.999, see, really what I'm doing here is I'm doing the limit as x approaches 2. I'm letting the x approach 2 here. If I do that, what do I get? 3.999. So the closer I am to 2, the closer this number will be to 4. Now this shows 2 here because it just rounded the number here. It actually didn't type in 2. Here's the number that's typed in, 1.999. If I go closer, 1.99999, then I get a number even closer to 2. I can show more digits here to show you that I'm not typing in 2 by increasing the number of digits shown right there. So the limit as x approaches 2, what is it? It's 4. And it's as easy as typing in a number very, very close to 2. And you could try on the other side of 2 also, like 2.000001. Let's try that. What do I get? 4.0001. So the closer I get to 2, the closer this gets to 4. So you can do problems that way. But another way, well, I'll tell you what, also looking at the graph, here's the graph from 0 to 1. But if I look at it from, let's go make sure that 2, an x value of 2 is within there. So let's go from 0 to 3. If I do that, you can see this white spot here And that represents, let's get back to it, that represents a hole in the graph. Now where is there a hole in the graph? At x equals 2. There's a hole in the graph. What's the height there? 4. So the limit as x approaches 2 is 4. It's actually an undefined point, and this is showing the undefined point. There's actually a hole in the graph right there. The graph goes along, and then it skips this spot, and it starts on the other side of it. There's no vertical asymptote, though. There could have been, but this one doesn't have a vertical asymptote because we checked it out. We did a little bit of analysis there to see what was going on. Now, how else can you do these? Well, if you remember how to factor expressions, you could factor the top difference of two squares into x plus 2, x minus 2. The two x minus 2's cancel out, and you just have x plus 2. Now I can substitute in 2, and I get 2 plus 2 is 4. So the limit as x approaches 2 is 4, right there. So that's a good way to do it too. So you can either factor and cancel things out and then evaluate it into the factored expression. You can put numbers that are very, very close to that value in here. Or you can graph it and see if there's any holes in the graph. Okay, let's go on to the next one here. So the next one, find any undefined points for this function, x minus 2 over x squared minus 4x plus 4. Well, let's go ahead and put the coefficients into Excel. So we have an x minus 2, and so going up here, we have x minus 2, and in the denominator, we had x squared minus 4x, and I think it was plus 4 right here. If we take a look at this, it's kind of confused about all the possible undefined points. So let's see if we typed it in right, and also let's make sure, let's see what we're looking for on this problem. And yeah, it is typed in right. And what we could do right off the bat is factor the expression. This right here factors into x minus 2, x minus 2. Factors of 4 that added up to negative 4, minus 2, minus 2. The x minus 2's cancel off, and now we just have 1 over x minus 2. Well, the x minus 2 is still in the denominator. We didn't completely cancel it out. And when you have that term remaining in the denominator, then it's going to give you a vertical asymptote. So this thing actually has a vertical asymptote at x equals 2. So the limit as x approaches 2 on this expression is infinity. And we can see that right here. Let's get close to 2. See, here it is getting close to 2. And what is the graph going? Well, it's going vertical in both directions. So to be precise, this limit doesn't even exist because on one side it's heading off to negative infinity, and on the other side it's heading off to positive infinity. So the limit doesn't even exist on this particular problem. If we look at it maybe farther away, I don't know how far, but you can see that it's heading down real sharp and up real sharp. So the limit doesn't even exist on this because it's not heading, both sides aren't heading off to positive infinity and both sides aren't heading off to negative infinity, and they aren't getting close to a specific value. They're going in opposite directions at 2. So the limit does not exist. And that would actually be the answer to that problem. There's a vertical asymptote there. Okay. Find any undefined points for this function, x squared minus 4x plus 4 over x minus 2. Okay, well let's take a look at this one. Let's put in our coefficients. So here it's just a flip-flop of it. The x squared minus 4x plus 4 is on this side, and over here is just a x minus 2. So let's put that in. And now that's what this graph is looking at right here at this point. And let's make sure we have everything correct on this. And it's x minus 2 in the denominator. And we're looking for any undefined points and so on. And again, with the factoring, it's pretty nice because the top factors, and then all you have to do is cancel out, and you're left with x minus 2. Okay. And then what's happening as x approaches 2 on this? Well, 2 minus 2 is 0. So the limit as x approaches 2 on this function right here is 0. And we might be able to see that on the graph. Let's take a look as x approaches 2 on this. And we can see that the graph goes through this spot right here, which is a height of 0. So the limit as x approaches 2 is 0. Now it doesn't show the hole in this graph here. Maybe it would if it was a different start and end. Let's try it from 0 to 3, and there it shows the hole in the graph right there. So these holes don't always show up. It depends on your viewing window here. But you can see there's a hole there, but still, even without the hole showing up like we had before, you can see that it's approaching the same spot, 0, a height of 0 on this. And again, if you put in 2 in this, you get division by 0. Well, that's because there's an undefined point there. But if you get close to 2, you can actually see what it's approaching. Like if I try 1.999, what do I get? Negative 0.0001. It's getting very, very close to 0. If I try on the other side of 2, let's try 2.00001. What do I get? A positive 0.0001. So it's getting very, very close to 0. And I think that should do it here. Let's see if we hit everything. Yeah. And now we'll come back and do this in the next video.